Let's go ahead and get ourselves going then. Looks like a lot of people are on, and I don't know, you got to be in pretty good shape for getting going. So let's go ahead and get ourselves going. So this is session 16 of the class. We are going to be doing it remotely today. I apologize for not being able to get on back down to Stanford this afternoon. I got called into a meeting where we had to stay up here to do something this evening, so I couldn't make the commute work out. But this will be the last online class. For the rest of the quarter, we are here live to go ahead and help out with the check-ins as well as just kind of do things in class. So hopefully this will be the last time we have to do it this way. Thank you all for joining us in this different form. Please go ahead and jump in at any point. I know it's a little bit hard when we're not in the same room because I can't see kind of you face to face, or if you have a question, normally it's easy to kind of spot you and raise your hand and things like that. But don't be shy about that in terms of jumping in the online form. I'm leaving all the microphones unmuted. Just go ahead and jump in with your voice. That's the easiest thing to see. Or go through and type a message into the chat window. And if I'm not seeing something in the chat, Lottie and Raj, could you please go ahead and just pop in with a voice to let me know that there's something hanging around out there that we need to stop and do. Because what happens is when I switch over to Revit, I don't see that window anymore. So that'll help me out too. Okay, so in terms of what's happening, we're really moving into the last phase of really what we'll be doing in terms of different types of new systems. Today what I'd like to do is talk a little bit more about plumbing systems, and specifically plumbing systems that are a little unusual. There's the basic sorts of water and sanitary systems that we've been talking about in the past, and those we understood pretty well in terms of what was going on in 120A. We'll kind of look at it a little bit more today, but really what I'd love to do is kind of start looking at other types of plumbing systems, things like gray water systems or rainwater harvesting systems or even sprinkler systems, and they all work very, very similarly. The nice thing about most of what happens in Revit MEP or within these MEP systems modeling is that it actually works out to be a fairly similar process where we have different endpoints that need to be served. We have things that supply water to them or take waste away from them, or tanks that collect things. And it really gets down to, instead of running ducting, but running piping between the different elements. And we can use the tools to size the piping after we place it based on what the actual loads are that are being modeled in the systems. So it really is all about systems design, not only sort of putting things in to the model to make them look good graphically, but ultimately to make sure that you have an accurate model of really what's going to be going on with the functionality of the system. Let me do this. I realized I didn't show my screen yet, so let me show my screen. And let's go ahead and just point you towards some of the materials that are available to help us understand where we're going today. So at a high level, if we go switching on over to Coursework, let me do that. Take a look at that. You'll see that in the session 16 folder, you will find, what's it doing here? I swore I had already done that. I'm wondering what login this is even talking about here. There we go. Okay, we have several different examples out there. We have a building example in Revit that we'll be working with today. So if you want to follow along, please download that. It's really just where we left off last time with a few plumbing fixtures added to it. We also have some references for you. We have a water and sewage system reference from the Ching Building Design illustrated book that I love so much. We also have a couple sections from its mechanical systems design course. Grunzik, as well as many other authors put together. It's really a fantastic book. It's all about building systems integration, and there's a couple specific sections we abstracted about gray water systems and rainwater systems, just to kind of talk about some of the specific requirements. So, just as we get going, let me go ahead and open up the Chainbook and kind of look at a high level about some of the information in there. In general, as we think about systems, there's supply systems as well as systems that take water away. Actually, let me do this. I'm going to open it up in my PDF reader instead. It's a little bit more fluid than what's going on. So I look at it online that way. But please go ahead and download it that way. Let me pop out of here. Go over to session 16. And we'll get to that same reference. think that'll pull that window over, make that a little bigger, and see if we can make that make sense. Yes? Let us see why that is. Hang on. Show my screen. How about now? I think maybe I might have hit a pause in there somewhere. Thank you. Very good. Thanks, Wira, for pointing that out. Okay. So, looking at this reference, there's a lot of kind of very useful information here. And the important thing to think about water systems, both on the supply side and on the sewage side, is really, the understanding of really how water pressure ultimately allows the water to get to the final destination. What tends to happen is on the water supply side, these systems are pressurized. So if they're coming from a well, we often kind of take them into sort of a pressure tank, which feeds up into the building. What happens in a larger building in most city contexts is we'll do something that looks a little bit different. Let me see if I can get a page forward to it. I'm saying go down, and it doesn't want to seem to be cooperating. We'll figure out why in a second here. What's going on with Acrobat? Seems like it's locked up in some way. Nope, there it is. Okay, here we go. So, go flipping on over. In most large buildings, though, as opposed to strictly depending on the water pressure just from the street coming in, what ends up happening is we set up a building system that's a little bit different, where we'll actually pump water in to the building, pump it up to a tank, which will actually be up on one of the higher floors of the building, and then use gravity to feed it down to the different urinals and the plumbing fixtures and just all the different endpoint sources within the building. And an important thing to know about this is that depending on your height of the building, you may actually have many different tanks like that that are feeding things down. What tends to happen is for water pressure, the height of the tank relative to the end point, the tap that's actually using it, that height difference really does a lot to sort of influence what the pressure is, and we can put little pressure valves in there to go ahead and moderate that. But if you have a tank which is much, much higher than the end point, you'll have very, very high pressure water. So we try to moderate that so that you don't have incredibly high pressure on the lower floors where the height difference is so great, and then much lesser pressure at the upper floors. But the whole idea of bringing water up to a tank and then like grabbing it, feeding it down, is actually a very common approach in a lot of big buildings. So you have a sort of a ready reserve, and you're not as subject to fluctuations in the main water supply throughout the city. It's really one of the things where you'd like to go ahead and not depend on the pump pressure, but you can even pump it up to these tanks at off times, like in the middle of the evening, and then feed it down into the day when it's, we're using the power at night when it's a little bit cheaper, and then ultimately using the power or just gravity to feed off of it through the day, which tends to be a pretty good approach. Okay, in terms of the uses and how much demand each of them creates, every different fixture you put on there has a certain flow, a certain number of fixture units that it creates, and things like water closets tend to be one of the bigger users, like 6 to 10 fixture units, urinals 5 to 10 units, things like lavatories where we wash our hands, really not so bad. Yes? Yes, Lottie? Oh, please, let's go ahead. Okay, so let us see what's going on here. So we'll roll on back. So starting with being wrong, will the water pressure from the mains be sufficient to reach 2 or 3 stories? Very often the water coming into a building is pretty high pressure, so it's enough to kind of take it up there. But sometimes what we do is even in the basement of the building, go ahead and have a pump, which will go ahead and give it the higher pressure to go up. So you might have a tank at the bottom of the building, and then add pressure to it to actually get it up to, if you need to get up to an 80-story or 100-story building or something like that. So if we need to pump water, can we do direct boosting so as to eliminate the rooftop tanks? And yes, you can. So it's really just a matter of whether you want to do the direct boosting all the time or whether you want to kind of pump it up to a tank and depend on gravity. And different buildings and have different philosophies about how to do this. So you can do it all as directly just feeding it up as opposed to gravity. In fact, on the second page of the handout here, let me go back over there and see if I can get to that. It actually sort of talks about that a little bit down at the bottom here. That you can just go ahead and just feed into the building and then use pressurized tanks to go ahead and push it up to the appropriate height. But what tends to happen with all these systems is we need to sort of control the pressure greatly. You really want to have this thing where you have a relatively even pressure, so that whether 100 of different lavatory taps are on or only one is on, no one gets blasted by extremely high pressure based on the overall loads in the building. So we tend to segment systems into a lot of little parts with pressure valves to make sure that we don't have to put an incredible amount of pressure behind the entire system, or no one sort of runs out of pressure at a time because we all decide to take showers at the same time. So that whole notion of moderating pressure actually is one of the biggest considerations in terms of like trying to design a water supply system. Okay. So any others in there? No, those are sort of the biggies in terms of what's going on. These are good questions because this is really the heart of really why we what's difficult to design in terms of these systems. After we've supplied the water, often we get to the whole issue of how we drain the water away. And draining the water away typically goes to a sanitary system, but it could also be going to a gray water system. We'll talk about that a little bit later today, where generally we use gravity to go ahead and feed water out. We tend to, at the bottom of all fixtures, have something called a trap. Let's talk about that. Oops, pop back over here again. Actually, go back up to that one. Page 5 was the better view. The idea of a trap is that, as things are being fed down through gravity, there's actually air in the system, air that ultimately needs to be vented out, because when we're depending on gravity, if we don't have air behind the water, we'd have like suction. We'd actually kind of be creating like a siphon, and we wouldn't want that. If we don't have, if we have air flowing back to the system, which is necessary to get the water to drain without creating a suction, what we need to do is go through and actually have a way of preventing the air from getting back into the building. Okay, because that air tends to be not very fresh. We'll call it like sewer gas. It's typically contaminated with all the odors of the sewer system. So what we tend to do in the bottom of most sinks, in the bottom of toilets, in the bottom of most drains, actually have this little kind of small area that we'll call a trap, which stores some water. And that water is really just all about sort of providing a block for the air. As new water is flushed through the system, that block is removed. It'll flow through there and water will be left in its place. So even after we flush out a sink or we flush a toilet, the last little bit of water actually stays in the trap. So even in the bottom of a wall-hung toilet or a kind of gravity or a floor-mounted toilet, you still tend to have these little kind of traps in the bottom, which are all about preventing that backflow. Okay, you don't want the air kind of getting back in there. Okay, and that's part of the design of the sanitary system. There's all sorts of connections for doing that. But in the sanitary system, at the end of the day, we go through and we have a combination of both drain lines. Let me kind of zoom in on this a little bit, hopefully make it a little bit clearer. Will that zoom in? Maybe not. We do it. There we go. We have both drain lines coming out of the fixtures, so out of the bottoms of sinks and the bottoms of the toilets, but we also have ventilation lines which come up and then ultimately feed out to the roof of the building. Okay, and what do those vent lines do? There's not water flowing through there. There's really just air flowing through there that's actually allowing the water to flow out. Okay, so a good drainage system actually has both those components. Has both the water draining out and also has the air kind of coming back in, so that everything flows nicely. The other thing that you need to know about drainage systems that we talked a little about in 128 is that the drain lines need to have a slope on them. They slope from the source all the way down towards a central riser. This is going to go dropping down between all the different floors, and it needs to be at least 1/4 inch per foot. And that's to kind of keep everything moving by gravity. If that didn't happen, some of the solid waste could get stuck in the lines and kind of create a blockage. Okay, so need to watch out for that as we're going through and placing them. So water, cold water and hot water lines, those tend to be under pressure. They can be at any elevation, but drain lines we need to go through and add that little bit of slope. Okay, so let's go ahead and start with that and just try connecting some really basic little systems. And this will be similar to what we did in 120A, but it'll give us a starting point for actually doing the transition to thinking about sort of more complicated systems. So let me start with that. And to do that, what I'm going to do is move on over to Revit. Okay. And I've actually opened up that session 16 start. In that model, there are actually already some pipes placed for us. Like I'm moving the model as opposed to doing my zooming. Hang on just a second here. Try it again. I'll zoom on in here again. And you'll see there's a couple of different pipes in here. There's a sort of a hot water line, a cold water line, as well as a sanitary line. Let's talk about how those got there and how you can get them there too if you haven't had any experience, because it's actually pretty quick. What we're going to do is, what I'll do is just take these ones out. I'm just going to backspace those to start with. Okay, so now I just have some fixtures. I have a urinal, I have a toilet, as well as a sink, a lavatory here. And each of those different fixtures have ins and outs on them. So on those, you know, for the toilet, there's a 4-inch out, there's like a 1/2 inch in with 10 fixture units, 4 fixture units out. The urinal just has cold water also coming in, a fewer number of fixture units on a 3/4 inch line, a 2-inch line going out. And over here on the sink, we actually have a hot and a cold, as well as the sanitary going out. So we have those different units. As you're placing things, if you haven't placed elements before, and this is new, what you do is under the systems, you can go through and place plumbing fixtures. You can load in some plumbing fixtures. And let's talk about the difference you need to know about in terms of plumbing fixtures. If you go down into the plumbing category, there are really 2 different subfolders in there. There's an architectural folder and an MEP folder. They look amazingly similar because you'll find toilets and urinals and water closets in there in both sides. When we are doing systems design, we actually want to use the MEP versions because the MEP versions are ones that actually have the connections. They have the ins, the outs, and all the flow information. So if you're working with fixtures that don't have that information, it's just that we have the architectural version, not the MEP version loaded. Let me kind of even sort of illustrate that for you. If I come on back to the plumbing, and I'll go to the architectural, and see if I can grab a toilet out of there. So a water closet here. See if I can place this somewhere. Okay, I'll put it on that wall over there. Okay, not a good architectural design, but it'll illustrate our point. These 2 toilets look amazingly similar, but you might notice a small difference between them. This one over here actually has a little more piping to it. You can sort of see a drain pipe kind of going through the bottom of the bowl right there. And if I click on that one, you'll see that it indicates that there's some in and out information. If I click on this one instead, you'll see that it doesn't. It's just an element. It's just a our spatial element. Yeah, so it doesn't have that systems information. So if you've already gone ahead and put some things in using architecture elements, go ahead and swap them out if you can. You can go through and I have that architectural element there. You should be able to go through and change to a different type. So, there's currently, for a public building, kind of a relatively low flush one, I'll just swap out the type here. Actually, it says it's not going to let me do that just as a swap, so I might have to go ahead and delete it and replace it. I think it just has to do with the way the thing is hosted. So not to worry. I'll just come over here, take that one out, put a new one in there. Actually, the better order might have been to go through and put it in there on top of the old one, just so I can get the location information before taking out that one. You put that fixture in. trying to stick to the floor. Let me see if I can place it on a face. What I'm trying to do is not place it on the face of the floor. I'm trying to place it on the face of the wall over here. I need to see if I can get it, convince it that it wants to do that. That's just rotating it. Let me do it from a floor plan view. That might be a little bit easier. Whenever I'm doing things in 3D, you'll remember I always get myself in trouble. So let me go to the floor plan view, try placing it there. Plumbing fixture, I'm going to place it on, there I get even the choice of a vertical space, which is even a little bit better. So now I can put it right on that wall. And again, I know it's the right one because it has the ins and outs. So that has, if you click on it, some in information. Okay, there's actually some out information in there too. Okay, but once we've gone ahead and placed some units, the basic idea of placing the main pipes is as follows. You know, we're going to put some pipes in here. We're going to put some pipes in for hot water, cold water, as well as the drain line. And as we're thinking about putting pipes in, the important thing is to sort of think about the height at which you want to run the different systems. For example, okay, on the Systems tab, I can choose pipe. Let's just kind of think about different types of pipe that we might want to run. The drain pipe is probably, the sanitary pipe is probably the most complicated one because it involves a little bit of slope. So as we go through and we think about placing a pipe, the drain pipe typically is a good place to start is say 4 inches in diameter. Depending on how many different drains are going to come together, it might have to ultimately be a little bit bigger than that. That's probably a pretty good starting point. And every pipe has a system it belongs to. So I'm going to put that into a sanitary system right now. And also think about how high off the floor it's going to be. Now, drain pipes I'd like to put very low to the floor or even below the floor if we have a multi-story building. So I'm going to let that actually be very close to the floor. I have a choice up here of whether to go through and have no slope or have it slope down or slope up. This just has to do with the order in which I'm going to draw it. Am I going to draw it from the downhill side up or the uphill side down? I'm going to go from right to left, or left to right, excuse me, sort of assuming that it's going to be sloping towards the center of the building. So I'm going to say I have to slope down. I can even choose the amount of slope. So I'll choose a quarter inch equal to a foot, or in a foot. So those information pieces, the offset, the type of pipe. Okay. It doesn't have to be copper. It can be some other segments in there. Let's let it be copper for now. And I will just actually run it even longer than it needs to be. I'm going to just run it from here all the way down. Kind of just take it off somewhere. Now, this pipe is showing up with a couple of attributes that are sort of interesting. It is a green line. Green is a color that's actually associated by default as part of the whole plumbing template, okay, with the sanitary systems. If you want to see that, you can better, as opposed to being a single line, we can actually turn up the coarseness or turn up the fineness of the drawing, and that'll actually give it a full width as opposed to showing it as a single line representation. Very much like with structural systems. Structural systems do the same thing. Single line representation versus seeing the full thing. Now, I have been drawing in actually the plumbing floor plan. You might be drawing in the mechanical floor plan. In the mechanical floor plan, notice that I'm not seeing it. So when the discipline is set to mechanical on a view, okay, I'm not seeing the plumbing elements. Okay, there's another drawing, another view in this file, which is the plumbing floor plan. Okay, the only real distinction is it's set to the discipline being plumbing, but you can change that back and forth. And depending on what you're actually showing right now, you may not see the plumbing pieces. I'm going to change it back to plumbing. I'm going to put it back in that part of the browser so I can make sure that I'm going to see it. Okay, so I got a basic drain line there. Let me go through to the 3D plumbing view and show it. And if I kind of rotate it around a little bit, you can see it over there. Kind of just running in the cavity behind those fixtures. Okay, but hopefully a little bit lower than the fixtures. I tend to like, again, everything to drain down to it. You can see in this view that it actually has that downward slope. Okay, so far so good. Let's stop and pause there for a second in terms of putting this basic drain line in, see how that's feeling with people. So we have any questions on that side? Oh, we got some scratchy audio there. Let's think about that in terms of, let's think about it. It could have something to do with just, well, it's probably, I'm wondering if it has anything to do with the thing that I'm wearing around my neck as a microphone. So anyone else having trouble with the audio? Let's kind of see if we get a sense on that. Yeah. Or is it, yeah, anyone else? Or Carol's not too bad. Lottie's okay. How about Julia? Are you doing any better now, or how's it feeling? Raj's is perfect. That's good. Not sure why. I wish I had a good solution for that, Julia. I'm not sure. Sounds okay? Okay. Well, I'm trying to figure that out. Don't know right offhand. I don't think I have a good answer for that one right offhand. Hopefully it won't be too awfully bad. You can still make it out. Thank you, Julia. Okay, appreciate it. Okay, let's go on back. So we'll switch back over here and put in the other piping. So the other big pipes that we're going to put in that are the main ones are the, again, the hot water and the cold water. And again, you guys have had some experience with that if you took 120A. Let's just go to the plumbing floor plan and we'll put those in. In terms of putting those pipes in, I'll say it's going to be a pipe. And for these pipes, let's go ahead and I'm going to change them up a little bit. For the hot and cold water pipe, I probably only need a 1-inch pipe. That's a pretty good starting point assumption. Again, we can kind of change that around a little bit later, but 1 inch is probably pretty good to go ahead and get ourselves started. I'm going to change the offset. For these, I actually tend to like to put them a little bit higher so they're not interfering with the drain lines. And, you know, we can sort of change it whichever way we want. I'm going to put low, for example, at 4 feet high off the ground. I'll make that my hot water line. I can change the system over there to say domestic hot water. Again, I can put that sort of even almost on top of that other line since they're going to be at different elevations. Or kind of offset it a little bit. That looks like it's back a little bit too far. It's running through the wall. I can move that in a second. Okay. Notice it shows up with red because it's a hot water line, and that's just a filter that's showing up, set to show it up that way, or display it that way. I'm going to go ahead and put in a blue line now for the cold water. So again, choose some pipe. And in the same sort of sense, I'm going to, although this time, change it so that it's not at that same 4-foot level. Oh, actually, let me kind of fix a mistake I sort of made over here. On that hot water line, I think I still had it saying sloping down, and it doesn't need to be sloping down. In fact, let me even go ahead and take it out, and I'll put it back in again so it doesn't have the slope. So I'll say systems, pipe. Okay, I'm going to turn the slope off on this pipe, make it 1 inch, put it at 4 feet. The reason I knew that it had sloped down was just that the height had changed after I drew it. So domestic hot water. Okay, there we go. Kind of running it off into space here. Eventually, these will all be tied into risers, but for right now, we're just going to kind of look at them in a very isolated system. Okay, so we have a hot water line in there. Let me go ahead and put in the comparable cold water line. So then I'll zoom in on that area and do a very similar thing. I'll take the piping. In this case, I'm going to choose a slightly different elevation. So I'm going to put it about 3'6" off the floor, just so they're really running at different heights. It's going to just minimize the conflict or the interference between the two different systems. I'll say cold water. And I'll put that in here too. Beautiful. Okay, I tend to like to run the pipes beyond the system. Okay, in terms of actually, as I'm working with little subsystems like this, to sort of minimize the amount of connecting in to the wrong location. So let me tell you what I mean by that. If I go back to the 3D view, or let me go to the 3D plumbing view, that's really the one I want, because it won't just sort of include all the mechanical elements, it'll just focus on the plumbing elements. Here's kind of the situation that I like to guard against in terms of putting these together. Okay, what we're going to do is actually connect these different fixtures to these pipes as a series of systems. It's going to be a hot water system, a cold water system, and a sanitary system. Okay, and what happens in terms of connecting things to systems, it actually works out to be pretty easy. We can go through and add things to systems pretty nicely. We can choose something, we can say that we want to connect it into something, it'll add it into a system, and it'll sort of implicitly be understood what it's all about. The problem sometimes is, though, that when we go through and we connect things into systems, Revit will try to choose what it considers the easiest route. And the easiest route sometimes will be to try to connect things to the ends of pipes, which isn't necessarily logical. You know, we would often want to go ahead and break the pipe, put a connection in there, and sort of a split so that there's a shorter length of pipe tying into those main ones. So here's what I'm going to suggest doing to kind of get around that. As you're thinking about doing your piping, go through and choose a pipe, for example, the hot water pipe or the cold water pipe, and say, cap the open ends. What's that going to do? It was so subtle you probably even missed it. It's really just right down here. You see, it actually put a little cap on the end of the pipe. Same thing over here. It's going to put a little cap on the end of the pipe. And why am I doing that? It's just so that I don't put things on that connection just because it looks like the easiest open pipe connection to go ahead and tie into. It'll sort of make it a little more accurate. We'll take that off in a little while, but that cap is just sort of a good thing to put on there temporarily as we're working. Again, let me go ahead and cap this system. And now as we're connecting in, it's going to do a better job about inserting itself into the middle of the pipe as opposed to trying to connect it to the outside of the pipe. Okay, so again, just choosing a pipe, and if you want to cap everything that's open, we can say, actually, it's not open now, so we won't be able to do it. Okay, so I want to tie some of these different things together. So for example, this little lavatory that I have kind of hanging around in here needs to be connected into the cold water pipe. Let's go ahead and connect it into, and we get to say which connection we want to bring it out. I'm going to say the cold water. Then we get to choose which pipe that was, and I don't remember whether mine was the upper or the lower. When I capped it, it sort of made it independent of the system. Put it down to the lower one. Okay, did a pretty good job there. In the same sense, I could take the urinal, connect it into. The urinal present what sort of elements it needs to connect to, and there's the domestic cold water. So I will tie it into that same piping system. Looks like that one. Finally, I'll do the same thing with the toilet. I'm going to connect it into. And also connect the, it's going to ask me which connector to use here in just a second. It's a little graphical goober right now. See if I can do that again. Oh, there it is. It just took a minute for it to draw it. Let's try it again. Connect into. Domestic cold water. And we'll tie it into that system. Oops, did I tie it to the wrong one? I might have done that. No, it looks like it's the right one. I'm going to leave that be for right now. It's warning me about something, but I think it's just a little confused right now. Let's see how we are doing in terms of thinking about this as an overall system. So we could choose that pipe. Right now it says it's an undefined system. Let's see if I can switch it back over. I think it's mad at me because I capped the system, so let me uncap it now. What I'm actually going to do is come to the end of the pipe over here and just remove that pipe cap. And now I should be able to choose that this is actually part of, it's still going to fight with me. I'm tabbing a little bit to kind of select the entire system. I should be able to select that and actually tell it that it's part of an entire system. Oh, that's the hot water right there. Okay, it's a little confused there, so let's see if I can go ahead and fix this right now, because it's really, where I got myself in trouble with capping it. Let me see if I can figure out what it thinks it is right now and see if we can fix that. If we want to sort of understand about the systems that are defined in the project, what we can do is do this. Under the View tab, you can turn on the System Browser. That's interesting. It doesn't think of it as being a system right now. Oh, hang on. It does think there's some elements here. Okay, that's a piping system. There's a domestic cold water system here. Right now it has, lavatory, urinal. It has a water closet in there. Okay, that looks pretty good in terms of what's going on. It should think of it as a domestic cold water system. It seems to understand it over here. What I'm sort of fussing with over on the other side is to get it show it to you graphically. So let me see if I can make it happen. Over on this side, what happens is if I choose a fixture, it's a little confusing in terms of my order of operations. Let me see if I can bail this out for you in terms of doing it. Because I think where I got myself in trouble is I was trying to be opportunistic about capping that system because I thought that would actually kind of help me out. So let's see if we can make this work. I'm going to choose that guy over there. I'm going to say create a system around it. So that's going to be, it knows that I'm already in the cold water system. Let me control undo that. I'm trying to think about how to get myself out of trouble on this in terms of that cold water system. Maybe I'll do the hot water system and then we'll get back, or do the sanitary system and we'll sort of figure out how to make that system understand what it is. Because the problem is, it's just a little confused about what its type is right now. We know that it is. It thinks it's an undefined system. But it's just sort of a little bit confused about the current state. So let me see if I can make this work a little bit better. I just took the pipe off the cap off the sanitary one. Let me see if I can redefine that as being sanitary again. It really, as soon as I capped them, it really decided to give me all sorts of trouble. Okay, which is a very unfortunate thing. Let me try uncapping it on this side again. You belong to I'm struggling a little bit to try and figure out exactly how my order of operations mess things up. So I apologize for that. But let us see, because it really, the key is we have to sort of basically get that into thinking that it's back to a sanitary system again. That pipe's lost its designation, and we don't like that. I'm going to take that pipe out and just put it back in again and see if we can get this figured out. Again, I'm going to apologize for the kind of roundabout way of doing this, but hopefully we'll make this work in the end. Systems. Pipe. Going to put it off the floor at 6 inches again. It's a 4-inch pipe. It's understood as being sanitary. I'm going to slope it down. And I will draw it again. I know that it's good because it shows up in green. So that's the part I like. So what I'm going to recommend is all my, what I was hoping would be very good advice about going through and capping the pipes to prevent things from kind of tying in bad ways. Seems to be sort of making a bigger mess for us than we want it to. So I'm going to say ignore that advice and let's go ahead and go back to tried and true. Okay, so I'll put that one in at 4 feet again. It's domestic cold water. It looks like it's trying to connect just because I sort of indicated they're drawn on top of each other. Actually, I want to say slope off on that one. Okay, it is blue. I know it's good. Okay, let's come back over here. We'll do the red one, and we'll make this work. So again, I'm going to apologize for this roundabout way of doing it. But there's a lot of things about piping that, well, vex me sometimes too. So don't feel too bad. It's just fighting with this stuff because complexity of doing a good job is sometimes cumbersome. Okay, in that case, I didn't choose the type. It still thinks it's cold water, but I should be able to change it. Let's come back over here and make it hot water, and then I'll make it red again. Okay. Whew. Let us go and back to that 3D view and go back to where we were. So the idea is we have our types now. So we're going to do that connect in again. Choose the cold water. Okay, notice it connected to the end. I'm going to leave it like that for now. I'm going to choose this guy. Connect him in also to the blue line. What will happen is, since the end of the pipe is already basically taken at this point, it'll connect it in sort of the way I want it. And even this toilet line, we'll go ahead and put in there now too. I'll connect in. Again, choosing the blue line. In this case, it connected to the end, which is not what I want. Let me undo that one. What you want to do with all these things is, as best you can, sort of route it in a way that, it gives it less flexibility. Or when you know there's a route that you want, you can kind of indicate what that route is that you want it to be. That's always sort of a better thing to do. Let me try this now. I'm going to try capping that again just because I'm hard-headed and see if I can actually make this work. Okay, that's a little better. It looks like after it's sort of christened as being a closed line or a cold water line, in this case, it's okay to cap it. Let's try now. I'll say connect in. Okay, and it did a little bit better. So definitely messy in terms of the whole notion of capping, but let's see if we can sort of make some sense out of this. I'm going to do sort of something similar. Actually, pause there for a second. Just going to give everyone kind of a chance to catch up because I know that was a confusing section in terms of what's going on here. Okay, sounds okay. Any general questions about that? I know this whole, it seems like the best thing to do is connect the pipe to one of the fixtures so it's understood as being part of a system. Okay, you want to sort of create the system, and then once we cap it, we're actually okay. When we make our HVAC and plumbing, should we create a new MEP project file? Can we directly place in the original Revit file? Okay, a very good question, and it's really a choice. You can put it all in the same file. You can make it in a separate file. In industry, often you'd make two separate files. So an MEP consultant would make their own file, and we'd link them together. Okay, but you can put it in your own all in a single file. It's really just a matter of, just how you want the complexity to be. So, since it's you working alone on this, it's fine to put them together into a single file. But often we put two separate files and link them together based on the coordinates. Okay, any other high-level questions? Super. Okay, let's go ahead and kind of take it a little bit further.